Video number 1 is on 7.3a trigonometry. This is for Honors Math 2. For those of you who don't know, I am away from my desk today because I am to go to a conference for pole vaulters in Reno, Nevada. So that's where I'm at right now, and attending meetings that are fun, exciting. So what we're going to do today is we're going to deal with trig. Trig is by far one of the most interesting pieces of geometry that has lots of applications. But I wanted you to see what you're writing down. I have 3 examples. I have a paragraph you're going to need to write down. I have one example, and then this information. So what I'm going to do is enlarge 7.3a trigonometry, and let you see all that information. Make sure it's on the screen right there. What I want the substitute teacher to press on the document camera is the button called Enter. When you press that, it's a pause button. You'll press Enter again to press play. Would you please do so now? And it sounds like you guys have all written down all this information, so I want to go through it with you so you kind of have an idea of what you wrote down and what you're learning about. Today you're learning trig. What we are doing with trigonometry is we're using acute angles to compare two sides of a right triangle. We might be comparing the opposite side and the adjacent side, or the adjacent side and the hypotenuse, things like that. There are 3 trig functions names, and those 3 trig functions are called sine. It is abbreviated SIN. So from this point forward, you're going to see SIN, but you're going to pronounce it as its full name, sine. The full name for COS is called cosine, but we will abbreviate cosine as COS. And then there's tangent, and tangent is abbreviated as TAN. And that's how we abbreviate the 3 trig functions. Now, what's interesting about trig to me is that they always reduce to the same ratios for the same angles because similar angles are proportional. This is like a very deep concept, this particular sentence that you wrote down. You may not understand it fully yet, but we will go more into depth with it later. If you don't understand what this means, don't worry about it just yet. I'm hoping after you see several things in 7.3b, you will have a thorough understanding of what this means. Okay, so what we're going to have to do is we're going to have to be doing trig on some triangles. We're going to be comparing two sides of the triangle, and sometimes we're using sine, sometimes we're using cosine, sometimes we're using tangent. So you're going to have to do these 3 things in order to be able to solve all the problems on the worksheet today. The first thing you're going to do is highlight the angle. What I mean by that is you're going to have to know which angle you are talking about. You're going to be highlighting the angle. You're going to label opposite. You're going to label H as the hypotenuse. You're going to label A as the adjacent side. These 3 things, O, H, and A, you are going to have to do every single time until you get really good at it. And then you'll be able to do it in your head. But what I like to remember this step as is I remember it as oh-ha. You're always going to start with oh-ha, 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 like that. It's so easy. It's so easy to remember. The first step is oh-ha-ha, Mr. Paramo made a joke. I feel so much better. So do you. O stands for opposite. H stands for hypotenuse. A stands for adjacent. The second thing you're going to use is this thing called Sohcahtoa. Sohcahtoa is an acronym where each letter stands for something so that you know what to do. For example, you're going to have to choose. Am I going to use sine? Am I going to use cosine? Am I going to use tangent? You will choose sine by using the acronym SO. SO stands for, the S stands for sine of the angle is equal to the opposite over the hypotenuse. The cosine, CA stands for cosine of the angle is equal to adjacent over hypotenuse. And TOA stands for the tangent of the angle is equal to the opposite over the adjacent. So what that means is I can see SO, I can see CA, and I can see TOA, but don't forget there's an angle involved there. You're going to be choosing which trig function you use based off of Sohcahtoa. First step, OHA. Second step, Sohcahtoa. Now, if you know those two things, then most of this unit will be easy. And I'll show you how it's going to work as we do some examples. But this last one, this number 3, is to give you a hint. You need to know two values, two known values. That's what that means. This is Mr. Promo trying to make this easier for you to understand. You have to use two values that you know what they are to find an unknown value or a value that you don't know. And then make sure, don't forget when you're doing these problems, don't forget to reduce your ratios. Put these in lowest. Let's write that down. Lowest terms. Okay? So let's do an example. This is in your packet. If you want to do it on your packet, you are welcome to do so. If you need to pause the video, press the enter button now. Number 3 says, write the ratios for sine of x, cosine of x, and tangent of x. So I'm going to highlight, basically, what we just wrote down. First thing we do, highlight the angle that we're talking about. When it says write the ratios for the sine of x, what angle are we supposed to use? X. Are we supposed to use y? Are we supposed to use z? No, that's exactly why number 1 says highlight the angle. This is the angle. I'm going to highlight it, see? I'm talking about angle x. That's important because your worksheet's going to change. Sometimes it'll do z. You will never use the y value or the right angle, just so you know. Now, when it says write the ratios for sine of x, let's just write that one down right here. Sine of x. I'm writing that down. To do the problem, we highlight the angle, and then we have to label the sides O, H, and A. OHA. So when I look at this angle, let's switch to a different color, please. Blue. What is opposite this angle is over here. I'm going to label this as O. O stands for opposite. Opposite what? Opposite the angle that was given. Oh, ha, ha, ha. H stands for the hypotenuse. So which one's the hypotenuse? That's the one across from the 90-degree angle symbol. That is H. And adjacent, in other words, adjacent is the third side. It's the side touching the angle that is not the hypotenuse. This is the adjacent side right there. I'm going to label that A. Now what happens is I've highlighted the angle OH and A, and I need to figure out what the sine of x is equal to. We've done step 1. Step 2 says choose the trig function. Sine, cosine, tangent. I need the sine of x. Which one am I going to use? I'm going to use SO. What is SO? SO is the sine of the angle is the opposite of the hypotenuse. Come back down here. Which one's the opposite? It's right there. Which one's the, oh, let me go back to red. The opposite is 4 root 5. So, opposite over hypotenuse. What's the hypotenuse? And this is what the sine of x is equal to. The only thing that we need to do now is what this thing says, which is lowest terms. The outside can reduce with the outside, and so the sine of x is equal to root 5 over 3. Don't forget, anything inside a square root can only reduce with other things inside square roots, but numbers that are on the outside, these coefficients can also reduce, and you do not need to put the invisible one there. So we have done the sine of x. You see how it works? Well, if that's easy to do, we've already labeled it. We're still talking about x. Now we're going to do cosine of x. I'm going to do cosine of x in blue because up there I have ca in blue. And guess what? Instead of so, now we're using ca. Ca is the abbreviation for cosine, is the adjacent over hypotenuse. You see how we're going to do it? Do you know what two numbers is going to go over? If you know what two numbers are going to go there in this fraction, write them down. I'm hoping you have 8 over 12. Ka, A over H. But I'm also hoping that you decided to reduce this and divide by 4, and get 2/3. The cosine of x in lowest terms is 2 over 3. We're just comparing two sides of a right triangle. And so the third one. Now the third one I'm going to do here in green. But before I do, because I do like to check for understanding, and even though I am not here, here's what I want you to do. What I want you to do is I want you to be paired up with somebody you're sitting next to. I assume somebody's sitting next to you. And what I want you to do is I want you, whoever understands it more, is going to explain to the person who thinks, I need help with it. That's what I want to have happen. And what you're going to do is you're going to say, this is how you get the tangent of x. You're going to use this, and you're going to explain in your own words how to do it. And so what I want is the substitute teacher to press pause on the video while students think, pair, share. Pause right now. And so now what I'm hoping is that you guys had tangent TOA. And you got something along the lines of root 5 over 2. Okay? Which brings us to the last thing that we're going to write down before we get to examples. This is the last thing I want in your notes right here is this little paragraph, please. Substitute teacher, you may need to press enter so that they can write down this paragraph. Coming back to you. You are going to be using calculators quite a bit this section. They are required. That's why I have a classette in my class. You are encouraged to bring one of your own if you would like. But I need you to make sure that you have it in degree mode. Now, I'm going to attempt to turn a little light on here. And oh, look at that. It does work. And I'm going to turn this on. And I'm going to point out something to you in this video right about there. I don't know if you can see it. That is the letter D that I am pointing at. That lets me know my calculator is in degrees. If I do not have it in degrees, the way I can check is I press shift, setup, and there's degrees, there's radians, and there's gradients. So I can go from degrees to radians and back and forth here. I would need to choose 3, and there should be a letter D there on this type of calculator. If you have a different calculator, you need to make sure you know how to make sure it's in degrees. One easy way to check is to punch in sine of 30 degrees. So if I actually type in here sine of 30, and I want to know if I am in degrees, it better come out to 1/2. If it doesn't, then you're in the wrong mode. And so I need to make mention here, in my higher level classes, being in the right mode makes a big difference. Let me turn that light off. We have to solve for variables that are in the numerator. If it is not, then use reciprocals to solve. I'll show you an example of that later. So let's amp it up. You are done with those notes. Now, if you want, you can either do this in your notes or you can put this directly onto your worksheet. I have numbers 4, 10, and 15. We're going to do number 4 first. I'm going to follow all the steps that I did before. First step I do, highlight the angle. So let me get my pen out. Boom. Here's my angle. Then my label says, number 1 says, label it. Oh, ha! Yeah, I remember. This is O, and the 14 is your H. Notice there's nothing over here on the adjacent side. You can put an A there if you want to, but I'm not going to. The reason I'm not going to put something there is because there's nothing there that I can use. Nothing I need right now. I need to figure out what X is. So when I look at this, I have an angle and I have an O and an H. I have to still choose which trig function I'm going to use. And the trig function I'm going to use that has an O and an H, is that So, Ka, or Toa? I'm hoping you know which one it is. If you said so, good job, you are on the right track. It's the sine of an angle. Now, which angle is it talking about? This angle is actually given to you. Because it's a measurement, we need to use its measurement. You see how that says 33 degrees? Let me shrink this down and move this on up. We've always had to have an angle as a part of our trig functions. Don't forget Sohcahtoa, even though there's an angle in all of those. So let's make sure we are incorporating that. Is equal to, what's the opposite? What's the hypotenuse? And so now, that's step 3 that you have in your notes. It says you can, or not even there, it's right here. Solve for variables that are in the numerator. Is your variable in the numerator? Variables in the numerator. My variable's in the numerator. Perfect. What's the opposite of divided by 14? Times by 14. So guess what X is equal to? It's equal to 14 times the sine of 33 degrees. Well, guess what that does? That is something we can punch into our calculator. So now I need to turn that light back on. 14 sine of 33 degrees. 14 sine 33 degrees. And I'm getting a little lazy here, but normally I type 14 times the sine of 33 degrees, end of parenthesis, but it's the same answer. The answer is 7.62494649. Round to the nearest tenth. 10th place, 7.6. And that's how we use the calculator, and that's how we can do it. What it means is any triangle that has a 33-degree angle, we can figure out what the side has to be if I know this distance here. That's what's interesting about trig. Trig is all based off of an angle, and then I know what the two sides are going to have to be. Maybe you don't understand, but hopefully it starts making more sense to you. Make sure you also know how to plug that into your calculator. Okay, you need to practice that to make sure your answer is the same as mine, because I'm only showing you on the calculators that I have in my classroom. If you need to know how to do it on your calculator, you'll have to ask me later. Going to number 10. Find the missing lengths in each right triangle. Round your answers to the nearest tenth. We're going to follow the same steps we did before. Highlight the angle. It says the missing lengths. So we're going to have to figure out what this is. I'm going to call this little t because it's across from big T. I'm going to call this little r. These are our two unknown values. And I have my angle, but I have to still go and do, oh ha! Across from there is O. Do you know which one the hypotenuse is? Do you know which one the adjacent is? Whoa. Now, if I am solving for, I can pick which one I want to solve for. What you do not want to do is pick two unknown values. You got to have two things you know. I know 50 degrees. I know the opposite is 10. Those are my known values. What do I not know? I don't know what T is. I don't know what R is. So you're only going to pick either O and A or O and H, but you would never pick A and H because those are both unknown. We do not want to have more than one unknown in our problem. So what I'm going to recommend is let's find T first, because that has something we don't know and something we do know, plus it gives me something else to talk about. I have an O and an A. O and an A. OA. I'm hoping you're thinking tangent. That's the trig function you have to decide you're going to use. You use your angle as well. Tangent of 50 degrees is equal to OA 10 over T. And now we have the tangent of 50 degrees is equal to 10 over T. And earlier we wrote down something. We said solve for variables that are in the numerator. If it's not, then use reciprocals to solve. Is this variable in the numerator? It's not. So let's use its reciprocal. Flip it. Well, if I flip the right reciprocal, if I flip this one, then I have to flip this one. If you don't know, this is over invisible 1. It's 1 over tangent of 50 degrees. Is my variable in the numerator now? Yep. Instead of divided by 10, what do we do the opposite of? We times by 10. So this one's a little different. T is going to equal 10 divided by tangent of 50. When you multiply by 10, you're multiplying by 10 over 1, so that's going to go in the numerator, by the way. When we plug this into our calculator, to our nearest tenth, we have to punch in 10 divided by the tangent of 50 degrees. If you want to use the fraction button, (10) divided by tangent of 50 degrees. It's about 8 point, round to the nearest tenth, 0.4. Now I want to show you one other way you can input this without the fraction button. You can do 10 divided by tangent of 50 as well, and you'll get the same answer, by the way. Calculator is required. Last example. Find the values of W and then X. We have a 70-degree angle. We have a 41-degree angle. Highlight the angle. This one is an opposite. This one is an adjacent. Can we figure it out? Which trig function would we use? Let's start with that. Are you going to use sine, cosine, or tangent? I hope you said tangent. Don't forget the angle. TOA 16 over W. Is your variable in the numerator? If not, use its reciprocal, which should be equal to the reciprocal of this side as well. Times by 16. Times by 16. The 16 multiplies the numerators. 16 divided by tangent of 70. When you're at this point, use your calculator. 16 divided by tangent of 70 to the nearest tenth. I'm getting about 5.8. And the last one. How do I find x? Well, this is 5.8-ish. And we have this. I'm going to label this. That's opposite. And with the 41, if I switch colors, let's go to blue. Opposite, hypotenuse. This side is the adjacent altogether. So I could use tangent again. 41 degrees is equal to the opposite over the adjacent, but my adjacent is this full distance. It's this x plus w. Instead of w, I'm going to put 5.8 right there. I'm going to jump over here. Is my variable in the numerator? If not, you'll need to use the reciprocal. Times by 16. That's getting messy, I'm sorry. And 16, that's in parentheses, by the way, so the 16 just goes away. You have x plus 5.8 equals 16 divided by the tangent of 41 degrees. Now, that's equal to x plus 5.8. If I subtract 5.8 from this, I'll get out what x is equal to. So this is a funky one. But I'm going to type in 16 divided by tangent of 41. Minus 5.8. And I'm getting that x is about 12.6. You can double check my math there, but I'm pretty sure I'm right. And that brings us to the end of the notes for 7.3a. I'm going to take a 10-minute break for you to start 7.3a before we jump into 7.3b. You can end the notes right here.